Hello, my name's Caleb Lalonde. This is my comprehensive video review of digestion, absorption, and elimination. So digestion begins in the mouth. Of food begins in the mouth with salivary amylase and lingual lipase. Basically, salivary amylase starts the digestion of amylopectin and amylose, where it partially breaks it down into maltose in the mouth. And then lingual lipase starts the digestion of triglycerides, where it transforms them partially into monoacylglycerols. So next, we travel down through the pharynx, through the esophagus. It is now called a bolus. It's a food bolus. It travels through the upper esophageal sphincter and through the esophagus and out through the cardiac sphincter and into the stomach. In the stomach, there are two main types of enzymes. There is pepsin and there is gastric lipase. Pepsin basically works to cleave bonds at the terminals of aromatic amino acids. So it looks to cut off proteins into just smaller peptide chains. It's not free amino acids yet. So right now we're in the stomach. Gastric lipase, what it will do is it will continue the process of breaking down these triglyceride molecules into free fatty acid molecules. Hydrochloric acid is also in the stomach, and this is very important because it denatures salivary amylase and lingual lipase. Basically, those enzymes no longer function, even though they came from the mouth, because the pH is so low, and enzymes tend to function at whatever pH they best work at, right? So in the mouth, it's not 2, but in a pH of 2 in the stomach, obviously pepsin and gastric lipase work the best. So as we travel through the stomach and into the small intestine, this food product is now called chyme. It's no longer called a bolus. Basically, travels through the pyloric sphincter into the duodenum, where this stimulates the release of two hormones, namely CCK and secretin. Secretin and CCK will activate the release of bile, and it will allow the release of pancreatic juices. In pancreatic juices, there are multiple things involved. Pancreatic acinar cells of the exocrine pancreas will release these juices, which contain sodium bicarbonate, pancreatic amylase, pancreatic lipase, trypsin, chymotrypsin, and carboxypeptidase. The thing is, though, these enzymes, a lot of them, especially for proteins, have to be activated. But starting with carbohydrates, we have pancreatic amylase. So what occurs in the duodenum, since it's the majority of chemical digestion basically happens here, is any remaining starches are completely digested down to maltose by pancreatic amylase. So maltose becomes 2 molecules of glucose, and any lactose or sucrose, lactose will become a molecule of galactose and a molecule of glucose, and sucrose will become a molecule of fructose and a molecule of glucose. Proteins, now a lot of them will be peptides. However, there are some proteins that I'm sure still exist by the time it hits the duodenum. What will happen now is the goal is to result in free amino acids. So we want free amino acids in order to be absorbed, right, later in the jejunum and the ileum. So what occurs is trypsin and chymotrypsin and carboxypeptidase and other peptidases like aminopeptidase. Basically what happens is this enzyme called enterokinase or enteropeptidase activates trypsinogen into trypsin. Trypsin activates chymotrypsinogen into chymotrypsin. Chymotrypsin activates carboxypeptidase or procarboxypeptidase into carboxypeptidase, and they cleave at various points along these peptide bonds and make them smaller and smaller and smaller until it goes from peptides and into free amino acids, where now it's ready to be absorbed further on. So next we have pancreatic lipase. So pancreatic lipase, in order for pancreatic lipase to work, fats have to be emulsified. So bile salts are released through the sphincter of Oddi in order for bile salts, or in order for fats to be digested properly. So basically, micelles surround fats and are packaged into things called chylomicrons, particularly large fats. So things like monoacylglycerols, or like triglycerides, will be broken down into these monoacylglycerols, and they will be packaged up and reformed when they are entered into intestinal cells. The same thing can happen with cholesterol and any large chain fatty acids. Now, some short chain fatty acids may travel just via simple diffusion right into the bloodstream, but the large chain fatty acids have to be packaged into chylomicrons, sent through lacteals into the lymphatic system, where it will eventually end up entering into the subclavian vein, and eventually the vena cava, and through the heart and through the bloodstream. So, just to recap, lactase digests lactose. It's a disaccharidase, a brush border enzyme. Sucrase digests sucrose, and maltase digests maltose. So now I want to talk about the absorption of these now broken down molecules. So as I mentioned about lipids, basically they're packaged into chylomicrons, the large chain fatty acids, and they are sent through the lymphatic system and into the bloodstream. Short chain fatty acids are sent just via simple diffusion. There's some controversy online. It's most commonly and widely known that lipids are sent via simple or passive diffusion through intestinal cells, but some areas say it may be facilitated diffusion. So proteins, but specifically free amino acids, are known to be sent through secondary active transport, and galactose and glucose are sent through secondary active transport, and fructose is sent through facilitated diffusion through intestinal cells. Again, at this point, cellulose will not be digested or absorbed. All it is to maintain structure and integrity of feces. So it's good because it's fiber, it's dietary fiber. So it will help propel this food and help keep shape of feces. So now moving on. After it passes through the jejunum in the ileum from the small intestine, it will go through the ileocecal valve and into the cecum, where, now known as feces, it will pass by the appendix. It will go through the ascending colon. It will go through the transverse colon. It'll go down the descending colon, and it'll go across the sigmoidal colon, where it'll be stored in the rectum. Basically, when elimination is getting ready to occur, the internal anal sphincter is controlled by autonomic processes. So it will release and allow the feces to move, where it will be stopped until the appropriate time for elimination by the external anal sphincter, which is controlled somatically. Elimination occurs out of the anus, and that is the end of my comprehensive review of digestion, absorption, and elimination. Thank you.